All right. Good morning, everyone. Happy Thursday, and welcome to Next UK. Thanks for joining us today. How are you doing today? All right. So today we have a great panel of speakers, including one of our customers from Bitly. My name is Liang. I'm in product marketing at Google. I'm also joined by Jeremy, Mahesh, Russell, and Nick, and we'll be speaking to you today about building an enterprise-class virtual private cloud. Now, before we get started, I'd like to remind you that these session surveys will be open in about 20 minutes, and please complete the session survey to allow us to get your feedback so that we can continue to deliver you great content for Next going forward. So today we want to talk to you a little bit about some new tools, products, and features that you can use to migrate your applications to Google Cloud. We start off by talking about super fast connections and also reliable connections on connecting your on-prem to GCP so that you can have a hybrid deployment. We then want to talk about bring your own IP on how you can break away from your on-premises and move to your public IPs into Google Cloud. And lastly, no workload migration is complete without having a robust set of security tools, and that's why we're also going to talk to you about packet mirroring on how you can collect and inspect traffic for your workloads. So are you thinking about migrating to Google Cloud? Well, if you are, remember that the network matters. The same infrastructure which our Google applications with billions of users are now available to Google customers like yourself. You can have a piece of our private network within our global VPC, which is available in any of our 20 regions. So Google Cloud Networking helps enable fast and frictionless migration with enterprise-class performance, reliability, and security. We also support application modernization at any pace with best-in-class networking for containerized applications. And lastly, we have simplified and streamlined network management with proactive network monitoring, verification, and optimization. So if you were at Next SF, you probably heard that we announced the beta of a 100 gigabit dedicated interconnect, or since then, it's been generally available. 100 gig interconnect provides 10x the capacity of our previous interconnect offering, and you can combine it with link aggregation groups to bring massive amounts of bandwidth to help move mission-critical workloads. You can also scale your connection capacity to meet your particular requirements and connect up to two 100 gig dedicated interconnect at Google Cloud at any of our POPs. In addition to dedicated interconnect, we also worked with a partner named CloudScene to launch Cloud Pathfinder for Google Cloud. And think of kind of using a Google Maps API, kind of like a Yelp type of experience. Search for how you want to connect to Google through your service provider of choice and find optimum connectivity pathway to Google Cloud with any on-net or data center worldwide using the app. And this is a free app to use. You can search and connect to any of Google's global nodes through any service provider. To access the app, all you have to do is go to find.cloud/Google. And the other topic on connectivity is that in Next SF, about 6 months ago, we announced the beta of high availability VPN. And our HAVPN is now in GA. With HAVPN, instead of having 3 nines of reliability, you have 4 nines. And for some of you, that might not mean a lot, but the extra 9 takes you from having 8 hours and 46 minutes of allowed downtime to just 53 minutes. That's a 90% reduction in allowed downtime. And with HAVPN, you can create HA connections between your GCP networks from your on-prem to our cloud. And we've simplified the setup so that if you want to go from your classic VPN deployment to HAVPN, the simplified setup will help with that experience. And with HAVPN, you can have 2 tunnels of capacity, and if one of them goes down, you're still in pretty good shape because that'll help you prevent from having downtime. So you heard a little bit about Google's global VPC some of our robust connections with HAVPN 100 gig interconnect, and also Cloud Pathfinder for Google Cloud. I'm going to introduce my colleague Jeremy to talk about how bringing your own IP can help you accelerate your cloud migrations. However, first, let's watch a video to learn a little bit more.
So you want to move your company's applications to the cloud, but don't want your IP addresses to change, potentially causing disruptions to your business and the customer experience. IP addresses are numerical labels assigned to each device connected to a computer network, and changes to them can cause major problems. Managing your IP addresses used to be one of the most challenging aspects of cloud migrations, which is why Google Cloud now allows you to bring your own public IP addresses to Google's network infrastructure across all regions. You can keep your own IP addresses as you move them from your on-premises deployments to Google Cloud, and you can use your IP addresses for these resources. Once you have brought your IPs to Google, we will provide public internet routing for those addresses. Changing IP addresses would require your partners and customers to build new whitelists and configure firewalls. But with Google Cloud, you can migrate your applications seamlessly since IP addresses don't change. There are many benefits to moving your IP address to the Google Cloud. Reducing networking infrastructure cost in your on-premises data centers. Minimizing downtime during migration, with minimal disruptions to your business and the customer experience. And preserving your IP address reputation. Allowing traffic from your endpoints to reach intended recipients while ensuring no one uses your IP address but you. And if a reputation problem does come up, you can resolve it on your own. If you ever want to move your IP addresses to a different cloud provider, or to migrate back to your on-premises deployment, you can take your IPs with you when you go. Once your IPs are in our system, you have more flexibility with the resources you already have. Google Cloud is the first cloud provider to have Bring Your Own IP available globally in all of our regions. You also have flexible IP address management that gives you control of your regional prefix sizes within your cloud deployment. It's time to see what moving your company's IP addresses to Google Cloud can do for your business. To learn more, go to cloud.google.com/VPC.
Hi, I'm Jeremy. I'm the product manager for Bring Your Own IP. I think the video does a good job of providing an overview of what Bring Your Own IP can do, but I'm here to talk a little bit more about some of the specifics. First thing I want to do is I want to talk about why you would want to move your IPs into Google Cloud. For the most part, people will migrate their workloads from their data center into the cloud, and when they're done migrating those workloads, in a lot of cases, they still have their IP addresses and infrastructure for their network hanging around in their data center. So with Bring Your Own IP, this enables you to get rid of that infrastructure or migrate that infrastructure, your network infrastructure, as well as the workloads behind it. This helps you save network costs, but also this will also help you minimize downtime because you're moving into a much more robust infrastructure. I think another reason for moving IPs into the Google Cloud is that you're able to, instead of readdressing everything, all your workloads, you can bring your IPs and not have to update DNS, not have to update firewalls, not have to update whitelists. Also, there's constantly the fear, I think, when you're moving into a cloud that you're not sure what is hanging around there in terms of a whitelist or in terms of something that's hard-coded into an application. These are the things that you don't have to worry about if you can migrate the IPs with your applications. So how's it work? Well, right now with Bring Your Own IP, we're doing the provisioning for you. We'll be releasing self-service interfaces in the future, but at this time, we'll be doing the provisioning for you. And so what we do is we break it down into 4 steps. First, you identify what we call a publicly advertised prefix. This is the prefix that you bring that we will advertise to the internet on your behalf. The public advertised prefix has to be owned by you. It can't be delegated to you from your service provider. And it also has to be prefix length shorter than a /24. This means nothing longer like a /25/26. Once you've identified the prefix that you want to bring to the cloud, you can then move into the validation phase. In the validation phase, Google actually takes a look at the route or the prefix and ensures that you own them, and also sets up the internet infrastructure so that you're aware of, so that our peers are aware that we will now be originating your routes. That's set up via RPKI ROA requests, as well as RADB updates. And finally, we will do a DNS challenge where we'll ask you to create a reverse DNS on one of your IP addresses so that we can validate that the person in the console is also the person that's able to make changes to those IP addresses. Once validated, we can then start the provisioning of delegated prefixes. One of the things that's really interesting about Google's Bring Your Own IP is we give you the ability to not just bring IPs into a single region, but we allow you to bring that publicly advertised prefix and then break it down into smaller prefixes that you can then delegate into regions or even to global resources. So for example, if you had a /24 that you brought to cloud, rather than burning the entire /24 in a single region, you can break that /24 into /28. This enables you to distribute a single /24 into 16 regions. Once that's done, that process is complete. Then we create the addresses in your projects that you've identified during the provisioning process. And once those addresses are created, you'll assign those to resources the same way that you assign any reserved IP address. You can use the same address list command or API to see what IPs are available, and all of the standard resources, CloudNAT, VM instances, network load balancers, global load balancers are available to apply Bring Your Own IP addresses. So just a real quick review. I do want to go over again because this part can be a little bit confusing. It's a little different than other providers. I'd like to talk a little bit more about the concepts. There are two concepts that are important here. One is the publicly advertised prefix. This is the large block that we advertise to the internet. So the publicly advertised prefix is just advertised. It's advertised consistently to all of our peers from our Bring Your Own IP ASN. Then the public delegated prefixes are the smaller blocks that you create from the larger block. Those can be delegated to regional resources. They can also be delegated to global resources. An example of a global resource is a global anycast VIP. Example of regional resources are network load balancers, CloudNAT, and VM instances. So finally, a little comparison about our Bring Your Own IP and what we're also seeing elsewhere in the market. So we're the first cloud provider to allow Bring Your Own IP in all regions. And every region that we bring up from now on will have Bring Your Own IP available. We also give you versatile IP address management. We give you the ability to break down your IP addresses and distribute them to regions as smaller prefixes so that you don't have to go out and get a /24 for every single region that you want to bring IPs into. This is compared to other cloud providers that allow Bring Your Own IP but may not allow it in all regions. They advertise the prefixes only regionally rather than globally, and they don't have the versatility of IP address management. So now that we've kind of gone over this, I'd like to invite Russell Holbrook, VP of Engineering for Bitly, up to this stage, and he'll talk to you about a real-world example where we've migrated a company into Google Cloud with Bring Your Own IP. Russell?
Great. Thank you, Jeremy. So hello, everyone. I'm Russell, VP of Engineering at Bitly. So my team builds and supports our web and mobile applications, our APIs, and our numerous integrations. We're responsible for shipping new features and functionality, but we're also responsible for application uptime, security, and performance. When I first started at Bitly, we were actually starting a data center move, this time from one physical data center co-location to another. That move took a long time and also took the resources of almost every department within the company. our migration became our customers' migration as they had to update their DNS records to reflect the new IP addresses. Now we're moving again, this time to GCP with BYOIP. And thankfully, that move has been contained to our engineering team, and it's made it seamless for us and our customers, all at no cost. So first, let me tell you a little bit more about Bitly. So over the past 11 years, we've become the gold standard in link management. Bitly is known for taking long URLs and making them really short. Now, we're known as the trusted, secure, and we work at scale. Our numbers speak for themselves. Our customers create 200 million new links each month, and we register 10 billion clicks during that same time. Our open and flexible API is leveraged all the time. We receive more than 900 million API calls each month. We're integrated into tools and workflows and used across all industries. In fact, 2/3 of the Fortune 500 trust us with their business. So why use link management? Link management improves visibility, shareability, and provides analytics to understand, measure, and engage with your audience, your customers, your users. We provide data protection, security, and availability, no matter when and where links are used, and without you having to worry about it. And we work at scale and offer both UI and API access to shortening, redirecting, managing, and searching for links. However, one of our most important features is actually the fact that we support custom domains for our customers. So some of the great examples are on the slides above, but our customers use these custom domains to provide a seamless, white-labeled, and branded experience to launch and measure their marketing campaigns, or to build links and deep links into SMS and app notifications. Unfortunately, these custom domains have a cost, and that cost is hard-coded IP addresses in DNS records owned by our company, or owned by our customers. This cost makes it very difficult to move data centers. So 2019 has been a busy year for us, one of investment and expansion. Our core business is doing well. We have thousands of customers with tens of thousands of custom domains, but we wanted to venture into new areas, building a data insights product, and also building out a global online sales channel. So provisioning hardware is slow, and being hosted in a physical data center didn't meet the needs of our goals. So we, like so many others, started to transition to the cloud, first moving our back-end services. Now, Bitly is built using a microservice architecture. We're primarily written in Go with a little bit of Python in the mix as well. We're a natural fit for GCP. In fact, the same white paper that inspired Bigtable also inspired our custom in-house time series database that we call Clickatron. We also wrote a distributed messaging platform called NSQ. We built it and then later spun it out into its own product. Using NSQ inside of GCP has been wonderful. We can take all of our event streams and then stream them into BigQuery, and use BigQuery for analysis, for audits, and also for future product development. We're also looking at Spanner as a possibility for increasing our speed, but also increasing our multi-region redundancy. But ultimately, we wanted GCP because we didn't want to remain forever split between a physical co-location hosting our customer-facing IP addresses and with our backend services in GCP. We wanted the simplicity of being able to have our primary systems all within one provider. And we certainly didn't want to be locked in again, having our IP address stuck with a single provider as well. So, like I said, we wanted to move to the cloud, and we wanted a multi-region architecture. But before GCP introduced BYOIP, no other options met our requirements. We needed BYOIP for 3 reasons. First, those hard-coded IPs delay migration. In 2016, it took us 6 months of near constant customer communications, asking them, pleading with them, to update their DNS records to move to a new IP. Thankfully, during that migration, we bought an IP space, having learned that DNS record updates are painful and slow, and also introduced an unnecessary burden on our customers. So we vowed never again to repeat that. And so without BYOIP, doing this sort of migration would be impossible. Next, we also incurred significant legacy networking cost during that 2016 move. We had to keep network edges available in our old data center that continued to accept traffic while our customers were updating their DNS records. So it came with considerable expense, and we're waiting for our customers to update their records, and which is unfortunately often out of our control. With GCP, the move is much simpler. We were able to take a test IP range and point it against some of our production domains in order to do performance and load testing and validate that everything was working before just simply flipping a switch and moving our custom domain IP address over to GCP. Last, a multi-region architecture was incredibly important for us. So as we roll out our online sales channel to customers across the world, we were able to use GCP's global load balancers to bring our network edge closer to our customers, all using a single set of IPs. This architecture will also allow us to create multiple redundant backends for our services, which increase redundancy, but also decrease latency for our global consumers. So what did the BYOIP migration look like from our perspective? Jeremy described a lot of the technical aspects. I want to sort of describe our actual experience. So first, I should caveat this. Months of moving services over preceded this. BYOIP will not move all of your services from one data center to another. However, I'm sure there's another session at Next that talks about that. Instead, the BYOIP switchover itself was painless. Like I said, we first moved a test range over. We conducted performance and load test against that range, gradually increasing the amount of traffic that we accepted on our GCP production front ends. Having gained confidence that that worked, we were able to just switch over the IP of all custom domains. When we did that, the result was nothing. No one noticed. We saw increased load to our front ends, as we should have, but everything seemed fine. Then, however, our global redirect monitoring data started coming in. And with that data, it was a huge increase in performance. So by moving to GCP, we were able to reduce our connect, download, and resolve times by about 50% around the world. This increase in speed would have been equivalent to months of dedicated engineering time. Now, since moving our IPs to Google, we've improved performance, minimized potential for downtime, and also significantly reduced our networking infrastructure cost by migrating our public IPs to the cloud. So you've just heard a bit about Bitly's migration to Google Cloud with the help of Bring Your Own IP. Next, I'd like to introduce Mahesh to talk about how packet mirroring can help you collect and inspect network traffic in the cloud. But first, let's watch a video to learn more.
And attacks have become common in the cloud space. Your organization needs advanced security solutions for detection and analytics to understand network anomalies to protect your business. But in public cloud environments, getting access to network traffic for those use cases has been challenging in the past. Google Cloud now offers packet mirroring. Packet mirroring copies network traffic and sends the traffic to security and monitoring applications, unblocking a key impediment to cloud migration. You can troubleshoot your existing virtual private clouds by inspecting network traffic at scale. With intrusion detection, application performance monitoring, and enhanced security controls. If you already use Google Cloud, this new feature allows your organization to natively find a security solution with no additional overhead. We offer this on all our machine types in all regions. So irrespective of which machines are running your workload, you can turn on packet mirroring. and you only pay for the packet mirroring your organization needs for troubleshooting security. Our rich ecosystem of partners through the marketplace can fulfill your specific advanced security use case, allowing you the ability to find a custom and cost-effective solution to security in Google Cloud. With packet mirroring, you can extract traffic of interest to quickly detect and respond to unusual traffic patterns or content that could signify a network intrusion, a compromised instance, or some other anomaly. Identify network anomalies from VMs to VMs, packets between end locations on the internet and VMs, or traffic between VMs to Google services in production. Additional benefits of packet mirroring include application performance monitoring. Minimize application unavailability due to service delays caused by network performance issues, and identify performance optimization opportunities in applications across hybrid cloud environments. Also, meet key regulatory and compliance requirements with the ability to store an original raw copy of network packets in a multi-tenant environment, as well as create alerts for data loss prevention risks. Packet mirroring offers robust security controls to detect network threats and anomalies and offers compliance in the cloud for Compute Engine and Kubernetes Engine. Visit us at cloud.google.com/VPC to learn more about how packet mirroring can help your organization today.
Good morning, folks. My name is Mahesh Narayanan, and I am a product manager for packet mirroring on GCP. I'll try not to move on this stage too much. I have motion sickness. So what is packet mirroring? The video did a great job in describing and giving you an overview, but what exactly is packet mirroring? As the name suggests, packet mirroring is mirroring of packets. It's as simple as that. By mirroring, I mean cloning, replication, duplication of traffic. So that's what packet mirroring provides to you. Now, why do you need packet mirroring? As the network complexity grows, you need a way to inspect traffic. You need visibility into who's talking to whom. As you are migrating more and more workload to cloud, you are accessing, the VMs are talking to each other, the VMs are talking to Google services, VMs are talking to internet. You need a way to understand who is talking to whom, right? If you have an application on-prem, you have, let's say, a commerce application, you need to understand and it's within a DMZ, you most likely have a tool that is collecting information about what kind of communication is happening with this commerce tool, right? The same flexibility is now extended to packet mirroring. Now, what are the use cases of packet mirroring? The first and foremost use cases of advanced security. You can do intrusion detection, anomaly detection, malware detection, and user behavior analysis. The other use case is of network troubleshooting and diagnostics. Some of us are network engineers or DevOps. You might be familiar with running TCP dump. This is similar, but on an entire VPC scale. You're not running it necessarily on a single VM. We take the responsibility, we provide you an API, and with that, you can run packet mirroring across your entire VPC. And lastly, for compliance and regulation requirements. Let's look at a pictorial view of how packet mirroring is set up. So you have your compute instances, a GC instance, or a node in a GKE cluster. All the traffic coming into a VM / GKE cluster or going out of these instances are packet mirrored, right? So as traffic is coming over an internet, over interconnect, talking to Google production services, all are getting packet mirrored. The other interesting aspect of packet mirroring is the collector endpoint, which is giving you a private endpoint, giving you the capability to set up a set of backends behind this private endpoint, which give you auto-scaling, health check capability. There is a pointer between the GCE, GKE instances, let's call them mirrored instances, and the collector endpoint. Let's double-click on that pointer a bit. So when I say packet mirroring is natively integrated into GCP, we are truly natively integrated with the SDN fabric. There is no decapsulation, encapsulation overhead on the software that is running on top of the backend instances. So what it means to you is no management or provisioning overhead and no performance impact, right? The other aspect of the collector endpoint is it's an internal load balancer that is acting as a collector endpoint. In the GCP's case, we do client-side load balancing. There is no middleware or an appliance or a device sitting in between that is doing load balancing. What it means is there is no single choke point. So you can expand your packet mirroring across all your mirrored instances, giving you massive scale. The other benefit is that from a pricing perspective, we are not charging you for the number of mirrored instances, right? So if you have one instance or if you have 1,000 instances, you don't pay on a per instance basis. You pay for the amount of traffic that you're packet mirroring. Compare this in a scenario where you have a lot of VMs which are isolated, so they're talking internally, and once in a while they have to go out to get a security patch or an OS upgrade. In our model, you are paying for only those instances when they are trying to go out and download stuff, right? But in another environment, in the other provider's environment, you're paying for all these instances, irrespective whether they are talking internally or externally, right? So from a TCO analysis perspective, you're paying a lot for just having packet mirror turned on these instances. The behavior that we want to drive in your network is to have packet mirroring turned on and to only pay when you're packet mirroring the data. So let's look at how packet mirroring is set up. It has two parts, the front end and the back end, let's call them. In the front end, you set up the mirrored instances. These are compute instances or the nodes that are running in a GKE cluster. You identify which VMs need to be packet mirrored. So this can be based on a subnet. It can be based on a tag. So if you have HR tag or finance tag on VMs, you can identify the mirrored instances based on those tags. Or you can be very specific and say, give the VM name or the instance name and packet mirror those. Now, on top of that, you can have additional granularity by saying, only this traffic from this particular VM needs to be packet mirrored. You can provide a CIDR block, and you can be extra granular. On the backend side, as I had mentioned before, there is a collector endpoint, which is an ILB. You can set up auto scaling. You can set up health checks to provide you, scalability. You also provide monitoring for packet mirroring, so you can figure out, how many bytes or how many packets were packet mirrored. And if there is an issue, that will help you figure it out. And lastly, we provide support for VPC peering as well as shared VPC topologies. So let's double click on the shared VPC and VPC peering topology. The first topology is a simple single VPC. You're ported over your commerce workload, and you want to packet mirror any traffic that is going outside of a VPC. So you can do that with this in this topology. The second one is a kind of a hub and spoke topology. Let's say you have 25 departments. Each department has their own VPC. You don't want to set up individual, packet mirror collector instances for each of these 25 VPC. You have a centralized security SecOps or a NetOps. What you can do is do VPC peering and kind of packet mirror all the data from all the different VPCs to this central VPC. And then we come to shared VPC topology, which is a very famous topology for our top enterprise customers. So in this, there are multiple combinations. You can have service projects running a GKE cluster or VMs, and you can run your collectors in the host project in the shared VPC. Or you may decide to have an environment where even the collector backends are in a service project. So your workloads are sitting in service projects, and your collector instances are also sitting in a service project. So we support different topologies. Going back to what Russell was saying, seamlessness. You have an existing topology. You want to use packet mirroring. We support all the existing topologies so that you can start using packet mirroring seamlessly. Lastly, for packet mirroring to be useful, we need some strong and powerful solutions so that you can analyze, visualize the traffic. In that regard, I'm happy to say that we have 10 strong partners who have integrated their solutions with us. With that, I'll hand it over to Nick, my colleague who's a Super CE, going to give you a demo on packet mirroring.
Thank you, Mahesh. So my name is Cristofaro. I am a network specialist with Google Cloud. And now that we've spoken theoretically how packet mirroring works, I'd like to show you guys a bit of a demo on 2 potential use cases for packet mirroring. The first one is specifically to application performance troubleshooting. So let's say you have an application and you want to determine, or the application's exhibiting performance issues, and you'd like to determine what may be the cause of this. For example, you may want to see, well, what kind of traffic is going to the application? I want to see what's causing these specific errors that I'm seeing in my logs, which may be generating performance issues. One way of doing this would be through packet mirroring, to detect really the traffic that's going there and analyze and understand the potential problem. And one way of doing this is using a couple of functionality within Google Cloud. And one of them is, if you do not want to use packet mirroring all the time, you can actually trigger these based on events within the environment. So one thing I will show you will be using, for example, stack driver logging, which may be logging application logs. So seeing some performance issues that the application may be logging, and based on that, triggering a function within PubSub, and PubSub initiating with Cloud Function the packet mirroring functionality to enable packet mirroring and start logging traffic. So in this case, you don't have to run packet mirroring all the time. You may only run it when you want to detect a specific instance of an application exhibiting performance issues or whatnot. It's completely customizable. In this case, I'll show you a basic example of how that would work. And again, on the rest of the topology, it's pretty simple. You have a web server group, which is where the traffic's going to be coming in from a global load balancer, and then going through packet mirroring. Packet mirroring will be forwarding this to a collector. Now the second use case is specifically on intrusion detection. So we spoke about intrusion detection and being able to detect malicious traffic. So in this case, you may have, for example, an application that's not protected against remote code execution. It may be it's an application that's legacy that you migrated, and maybe there's some legacy malicious traffic that cannot be detected properly. So in this case, an IDS would be useful for this. The IDS would actually let you report on these potential intrusion events that malicious traffic's happening, and then based on that, you could report on it. And using, for example, something like Cloud Armor could easily integrate with that and say, let's block traffic at the edge, so traffic from this malicious actor cannot no longer reach our application backend. So with that, I will show you how this works. Just one sec for the terminal to load here. All right. Okay, so this was supposed to be there, but obviously something happened. So, all right, so here you can see the packet mirroring policy right now is not enforced. So you can see it's disabled. So pursuant to our first use case, which we don't want to have packet mirroring enabled all the time, we have here a packet mirroring policy which is disabled. Here, as Mahesh talked about, there's different types of configurations that we could have. So for example, here, this is set for this VPC network, next 2019 Infra 200. The mirrored source is all VM instances in the subnetwork, and the collector destination is the collector ILB. And in this case, I'm mirroring all traffic, so I don't have any filters set up to limit the traffic that I want to mirror. I want to mirror all types of traffic. So what I'll do is I'll trigger this is a simple example of me triggering a 500 error code, so the application we'll see an error message and then detect, well, based on this, I'm not expecting this type of error. Let's log and let's start packet mirroring. So in this case, if I go back here, you can see now the enforcement's enabled. So how did that work? There's an application that logs some entry in Stackdriver based on that, and this could be any type of entry, any type of monitoring you're really looking for. Based on that, we're actually triggering a cloud function. So if we go in here and we look at the cloud function here, you can see that it detected an error, activated packet mirroring, and then it's started packet mirroring in itself. So if we go and actually log on to the collectors here, you could see that we would be starting a packet mirror. This is a simple TCP dump. We can actually see application traffic going on there. So this is the first use case, which is just simply triggering a packet mirroring functionality within Cloud Function. And then for the second use case, we'll actually have a look at an IDS event. So here, what I'll do, and here for the IDS, as you may have seen from the previous slide, I'm just running a simple open source IDS, which is with Brozeek. And in there, I have a specific module that's loaded for HTTP posts, so it can actually get me the content of the HTTP post headers, so I could see what's going on. So what I'll do here is I'll trigger a simple RC, basically a potential RC attack that would be happening on a back end. So here. So here I'm just doing a simple RC attack, which is trying to execute wget through HTTP post message, and in there I'm trying to reach an attacker-controlled website. In this case, the IDS would be able to detect this. So if we actually have a look here within the IDS, in the HTTP logs, we can see that it has the actual post header information is there. It's actually loaded here, so you can see that what content in the post message occurred. And then based on that, what happens is we're actually going to create, and this is depending on the IDS that you have. In this case, what I did is I created a function that, well, based on this attack, I don't want this attacker to start going through and potentially try to exploit me. So in this case, what happens is I can actually have a look at some of the information of what's in the HTTP post message and who the attacker is. And then based on this, and I can actually trigger a Cloud Armor policy to actually block this attacker. So if we have a look here now, just have to wait to refresh here. We could create a Cloud Armor policy that would actually block this traffic. So Cloud Armor itself takes a bit of time to actually enforce it, so I won't be able to show you this actually being enforced. But the idea is it really triggers a Cloud Armor policy to generate this rule to block this attacker IP. Switch back to the slides. So with that, you've heard a bit about the Google Cloud Hybrid connectivity options, how to bring your own IP, how can bringing your own IP accelerate your cloud adoption, how packet mirroring can help you with security analytics in the cloud, and you've seen a live demo of it. We don't really have that much time left for questions per se here, but we'll be sticking around, so please do find us if you have any questions, and we'll be happy to answer them. Thank you.